Google is making a big bet on fusion power, signing a multi-year deal with a company called Commonwealth Fusion Systems to build one of the latest experimental reactors at one of Google's data centers. The idea is that the reactor, which won't be operational for several years, will eventually provide low-cost, clean energy to run the data center, which in turn will allow Google to reduce the number of diesel generators it has to use as backup power. But this is too little, too late to help the company meet its near-term greenhouse gas emissions goals. According to its latest sustainability report, Google's total greenhouse gas emissions grew 35% from 2019 to 2022, driven largely by the massive amount of energy its data centers and offices consume. As The Verge's Sean Hollister points out, Google isn't exactly known for treading lightly on the planet, but like those competitors, it hasn't yet produced a sustained reaction that generates a net gain in energy. According to The Verge's Sean Hollister, who visited Commonwealth's facilities in 2021, the company has about 120 employees and has raised tens of millions of dollars in funding. While the reactors currently being developed by companies like Commonwealth won't be able to produce the massive amounts of energy needed to decarbonize the grid anytime soon, they could become commercially viable in the 2030s. If Google is right about this, it will have a significant cost advantage because it will have locked in a cheap source of electricity over the long term. Of course, that's a big if. There's no guarantee that fusion power will ever be able to deliver on its promise. So for now, Google's data centers will continue to rely on backup generators, which is kind of ironic given that the company is in the business of selling cloud computing services, are supposed to be both scalable and sustainable. But it is unclear how much money Google is investing in the company or how much energy the reactor will actually produce once it is up and running. Just last week, the company was called out for continuing to build data centers that rely on fossil fuels for backup power despite its public climate goals. Even if it does produce enough energy to offset the carbon footprint of a single data center, there are dozens of these facilities around the world. And according to Google's sustainability report, their total carbon footprint is about 1 million metric tons of CO2 per year. 1 million metric tons. By comparison, the largest fusion reactors currently in operation produce about 100 megawatts of thermal energy, not nearly enough to make a dent in Google's emissions. All of this is to say that Google's new fusion deal is more of a drop in the bucket than a real solution to the company's emissions problem. Still, let us dig into the details of the deal and what it means for the future of fusion energy. So the fusion reactor in question is being developed by a company called Commonwealth Fusion Systems, which is based in the US state of Massachusetts. Like many fusion startups, Commonwealth was founded in 2018 and is led by a team of scientists and researchers from MIT. Its technology is also similar to that of other startups in that it uses high-temperature superconductors to contain plasma and magnets to focus the beam of plasma into a small area, which generates high energy. The difference is that Commonwealth's reactor uses liquid lithium to remove impurities from the plasma, which makes the reaction more efficient. It also uses a solid-state power supply that doesn't require large amounts of cooling water, which again improves efficiency. Commonwealth says its reactor design can produce net power in just a few years, which is faster than many of its competitors. What is clear is that the reactor won't come close to powering Google's data centers anytime soon. Given all of this, the most likely explanation for Google's investment is that the company is trying to hedge its bets on future fusion technology. Thanks for watching. Do not forget to subscribe to the channel and join the Wolf Pack.